Welcome, guys. I welcome you once again to another video session on Math 332, which is numerical analysis 2. So, the first question here, we want to consider a particular matrix. I think this is a 5 by 5 matrix. So, we want to show that this matrix is a positive definite. So, how are you going to go about this? So, I think there's a particular short method to solve this, but that short method, you still have to um, evaluate a lot of expressions under it. Okay, that is the first question. And for the second part, they ask us to look for the inverse of this matrix. You know, the in 202, you can actually look for inverse of the highest inverse you can actually find is 3 by 3 matrix. But this is numerical analysis 2. So what if you now have 4 by 4 matrix and if they now ask you to look for the inverse of it, but without using the normal method that you know. But in this case, the method they now ask us to use now is partition method. I repeat, partition method. That's the method they ask us to use here. So I'll make sure I explain it too clearly. And at the same time, they ask us to solve this system A of vector x is equals to b. So I think that's what they ask us to solve. So looking at this now, it's not something that is really easy. It's not something that is really hard like that, sorry. It's not something that is really hard. So I want to look for the positive definite of this matrix. To look for the positive definite of matrix of this particular matrix that is here. So now listen attentively. You need to pick a 1 by 1 matrix from this. You need to also pick a 2 by 2 matrix, pick 3 by 3 matrix, pick 4 by 4 matrix until you stop at the 5 by 5 matrix. Pick all these matrices. Okay, you can actually select it out from this full matrix here. Okay, what is the 1 by 1 matrix? How can you pick a 1 by 1 matrix from here? Starting from this edge, this take not from the right part, starting from this first value here, pick a 1 by 1 matrix. Okay, this is it here, right? What if I now has to pick what if I now has to pick a 2 by 2 matrix? So that is this, right? This is a 2 by 2 matrix. So I'm starting from the left hand side, from the top left. This take note. This is 1 by 1 matrix. Pick 2 by 2. Now pick 3 by 3. So let me use another color for that. If I want to pick 3 by 3 now, is of this format 1, 2, 3, and 1, 2, 3. This is 3 by 3 matrix that I want to pick, right? This is 3 by 3. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. Okay, what of 4 by 4? If I want to pick 4 by 4 now, that will be 1, 2, 3, 4. That's from here to this point here, right? So then the 5 by 5, you have it completely right there. So to now show that it is positive definite, under what condition is this matrix said to be a positive definite? And I would like to tell you that when you find determinant of 1 by 1 matrix, find determinant of this 15. If you notice that the result is positive, oh, that is so blunt. Sorry for that. Let me change it. If you find the determinant of all these matrices here, and you notice that determinant of everything, each determinant of this one, if the determinant of everything here, everything or every matrix here, if the determinant is positive, the automatically everything no. If you notice that one of it is negative, the automatically is not positive definite. So you have to find determinant of this first one, find determinant of this 2 by 2. If it is positive, that is you have a positive answer. Okay, for every matrix that you pick inside this, if everything is positive, then we can actually say that this matrix is a positive definite in that case. So how are we going to go about that? And then I have to scroll down. Okay, the first matrix now, let's take it 1 by 1. For the 1 by 1 matrix, okay, should I call it matrix A in that case? For the 1 by 1, let's say we want to look for. So let me give you the solution. Let me just write the solution out. The solution. So the condition now is that if the determinant, okay, this is how I expected to write it. If the determinant of 1 by 1, 2 by 2, as I've stated, 3 by 3, the determinant of everything, no, 4 by 4, including 5 by 5, if they are determinant, if the determinant of all these submatrices, we call it submatrix, okay, submatrix of the given matrix above, of the given matrix above, if the determinant of these submatrices of the given matrix above is greater than zero. So if it's greater than zero, you know what that means. If it's greater than zero, that if it is positive, then we say that the matrix itself, the matrix given, then we say that the matrix given is said to be positive definite. So that's what it means. Now let's start. For the first part, let's find the determinant of the one by one matrix, which implies determinant of 15. Okay, determinant of a constant, of just a single constant, is determinant of a one by one matrix is always that same constant. It's always that same digit. So determinant of 15 is 15. So it's not greater than zero. So it's greater than zero. Satisfied. So now let's pick the 2 by 2 matrix. For the 2 by 2 matrix, we want to look for the determinant of, let's go, I think that should be 15, 4, then 4, 7. You can still remember that. Let's check. 15, 4, 4, 7. Abi? That's for 2 by 2. This one is for 3 by 3. This 15, 4 minus 2, 4, 7, 1 minus 2, 1, 18. That's for 3 by 3. So what's the determinant of this 2 by 2 now? That is, you put plus here, you put minus here, then you cross multiply. 15 times 7, you do that, put the answer here, minus 4 times 4, that's 16. So if you subtract it, you can do that yourself. I'm very sure you will get, this is 105. This one will give us 105. If you subtract it, that will be 89. So is 89 greater than 0 or not? Yes, it is greater than 0. Done. So just be praying that, actually, I already know the final answer too. I already know the final answer because they already told you that this is positive definite. Looking at the English itself, it says show that this is positive definite. So always pray that if you are trying to find the determinant, make sure you don't have a negative answer. And if you have a negative answer, that means you've done a mistake. So you need to go and check again. So now let's consider the 3 by 3 matrix and find the determinant. So the determinant now of this 3 by 3 is, okay, I want to put the determinant of 15, 4 minus 2, 4, 7, 1, and then we have minus 2, 1, 18. So to look for this determinant, use Saru's rule. That's the best method to use for this. But that's the shortcut you can actually use. Or you use your calculator. Calculator can actually solve 3 by 3. But that natural display cannot solve 4 by 4. The highest matrix you have there is 3 by 3. So when you get 4 by 4 on a stress, you guys show the workings, no matter what it is. You can't actually get that. Calculator can solve this for you. Calculator can easily find the determinant for you. But if you want to use house, no problem. Just repeat this first colon and second colon at the extreme. So see it here. I've repeated the first and second colon at the extreme here. Okay, and I'll close the determinant bracket. This is the 3 by 3 matrix, so I'm just trying to, I skipped the step. I should have written that first before writing this. So then after this, Sarusu says pick the middle value you have on the first row, the middle value, and then multiply the um the left to right diagonal starting from this position. The left, this for my left hand side now towards the right hand side diagonal. Multiply it together. That's minus 2 times 4 times 1. That is minus 8. Then trace it downward. Don't multiply the upper part of this line. The upper part of this line is 15, 7, 4. I'm not considering the upper part. I'm considering the down part. Okay. So then the down part now is that I will have to pick from here, left to right diagonal. Okay. Multiply it. 4 times minus 2 again. That's minus 8. Come down again and multiply this one. Okay. When you multiply this, you also have an answer. I don't know what that would be. I'll do that later. So then multiply this right from this same position. I've done the left to right diagonal, right? So now let's do from right to left diagonal. From my right hand side towards left hand side. So this is minus 2 times minus 2. That's 4. 7 times 4. And that is 28. Okay. Now let's multiply the, okay. I'm not, I said after drawing this line, you need to consider the down part. Okay, not the upper part. So I cannot multiply 4 and 4 and 15. I don't have any reason. I have to just come down here and multiply this. 15 times 1 times 1, that's 15. And then the last part, you have to multiply this one together. 4 times 4 times 18. So let me just assist by using my calculator. I have to use my calculator for that. So here it is, I want to multiply 4, 4, and 18. That's 4 times 4 times 18. I have the result as 288. And as for this one, okay, as for this last one, which is 15 times 7 times 18. I have it as 1890. So you sum all these results together, you sum all this one together. 28 plus 15 plus 288. Let's do it. 28 plus 15 plus 15 plus 288. That is 331. So let's add this one together. This one is minus 8, then plus 1890. Minus 8 plus 1890. I have this one as 1874. So therefore, the determinant of this 3 by 3 matrix is the subtraction of the left to right diagonal, the result of this left to right diagonal, and right to left diagonal. Left to right diagonal is this, the summation for it, the summation. So I don't even write it, sorry for that. The summation for this left to right diagonal minus summation of the right to left. And that's, this is equals to 1874. This for the left to right diagonal minus 331. So 1874 minus 331, I have the result as 1534. So this is determinant. See, this is very, very fast than using plus, minus, plus, pick plus 15, cross it. You have these two. It's going to take your time that way. This is faster. So I have 1534, which is also greater than 0, which is still positive, right? So that's for 3 by 3. So the only issue you have now is the 4 by 4. How can you find the determinant of 4 by 4? It's going to stress you a little bit. Okay, but still you have to show your workings. But there's no way you can actually try that. Okay, so and Sarusu cannot work for it. Sarusu does not really work for any square matrix that is greater than 3. That's greater than 3. Anything that you have more than, if it's more than 3 by 3 matrix, Sarusu will not work for it. So that is just the limitation for that. So for the 4 by 4 matrix, I have this result. So how are you going to go about this 4 by 4 to find the determinant? So these are the highest the advice I can actually give you to find the determinant of this one. But if you notice that there's not enough time, just you can't actually find the determinant. If you know it's going to take a lot of time, okay, inside the example, what you just do is, you already know that the question has to show that it is positive, definite. So you already know that this one will end up giving you a positive value. So if you don't want to go through any stress, just say the result here. You can just put a slight statement. It is believed that the determinant of this stuff is positive. Hence, the determinant of this result here is greater than 0. So you can just write the determinant of this one, just put greater than 0 directly. If you don't want to waste time. And for the last one too, greater than 0, then just make your conclusion. Since all these determinant is greater than 0, then it is positive definite. But if you want to show your workings, no problem. So let's check. To show your workings in this case, please and please, you have to show it one after the other. Use plus, minus, and then pick this positive 15 first. Okay, and then you look for the submatrix, the minor matrix. Cross it out. I'll have 711. I'll have 711. I'll have 118.6. I'll have 1619. Then you leave it that way. Next value is minus 4. Minus 4. Now look for the minor matrix. Cut this off, cut this off. I have 411 minus 2, 18.6, and I have 9, 6, 19, right? Pick the next one. Plus times minus 2, that's minus 2. That's minus 2. So then we cut it off. I have 4, 7, 1. I have minus 2, 1, 6. And I have 9, 1, 19. Pick the last one, minus 9. You have to do this one after the other without any mistake. Please take note. 118, 916. So when you have done this now, so if you now want to look for determinants, you can easily use your calculator for this one. You can easily use your calculator, or you use arrow. You know what you do for this one now. You repeat seven. You repeat this first column and second column here, and then you do it. Get your answer. Do it one after the other. So if you try to simplify this now, you use arrow for this. Use arrow for this, or you use your calculator. Calculator can solve this. Calculator can solve this. Calculator can solve this. Calculator can solve this. So, but if you don't want to do it that way, no problem. You can just go ahead and put greater than 0. So as far as you know that at the end of the day, if you find this determinant, it will greater than 0. So you can try to show that. But if you find the determinant of this expression here, you will get it as k. This one will surely give us, for the 4 by 4, you have it as 15386, which is greater than 0. For the 5 by 5, after picking each digits outside, you have 4 by 4. You still pick another digit again, you still have you still say na fucking stress. So you have to do it too. But maybe if I were here, I'll take time to solve this one completely. But when it's 5 by 5, me, I know we show the working, so I'll just put greater than zero. Then that's all. There should be a shorter way of doing this question. Yes, there should be a shorter way. But I prefer this than the other methods. So for the determinant of 5 by 5 now, you have this, you can try to solve it on your own. You have it as 136,571, which is still greater than zero. So since the determinant of all these submatrices is greater than zero, hence we can conclude that the matrix is what? Positive definite. And that's how it works. That ends the proof. That ends the proof for that. For the second question, which is 4b, they ask us to look for the inverse of, we are given a matrix A as 2, 1, 1 minus 2. That's for the second question. 4, 0, 2, 1. We are given this as 3, 2, 2, 0. And this one was given to us as 1, 3, 2 minus 1. They now ask us to look for A inverse. They ask us to look for A inverse using, not the way you used to do it too. They did not ask you to use that one over determinant of A, then times the adjoint of A. Okay, and this adjoint of A now is the cofactor, the transpose of the cofactor. So we are not using this method at all. They ask us to use the partition method. So what does the partition method says? This is a 4 by 4 matrix, right? So a partition method says you need to partition these matrices to the extent that you need any matrix that you want to pick first. Okay, if I can actually partition these matrices in different formats. Is either somebody pick, make sure that what you have towards the top left it must always be a square matrix. What you have towards the top left must always be a square matrix, and the determinant of that first matrix must not be equal to zero. So let's say I want to partition this now. Another person can just come and easily this can be partitioned to this format. Cross. Guys, I can partition it this way such that I have a matrix here. The condition is that whatever you have, this first part here, the determinant of this 2, 1, 4, 0 must not be equal to 0. That's the first thing you need to consider. If this gives you 0, and then that means there's a problem. But you don't have to be scared. I'm very sure any question that you'll be given, this first part will not be equal to 0. So let's check whether this determinant, if I find the determinant of this is equals to 0, cross multiply 0 minus 4. So I have minus 4, which is not equal to 0. So I'm free. So I can go ahead and use this kind of partitioning. Okay. What if another person can decide to just say, okay, I don't want to use this partitioning. I don't want to use this cross. The kind of cross me I want to use now. Can you use this? I already told you that the first expression you're going to have, it must be a square matrix. So another person can say, okay, let me use this. Why can't I use this partitioning? If you use this one now, it's going to be a lot of stress. Well, this first one now is a 3 by 3 matrix. So how will you be able to click the data is not equal to 0? So it will really take your time. So it's not advisable you use this. Okay. If I were you, I'll just go ahead and use two. I'll make sure that this first one will use always two matrix, 2 by 2 matrix. Please take note of that concept in that case. Okay, another person can decide to use, okay, what if I use this? This still a square matrix, right? So the determinant of these two is 1. So I can have different partitioning, but to be on the safer side for this kind of question, I believe you are smart enough to use this is the best partition that you can use. Okay, whereby this you can call this one, this another matrix here. I have another matrix down here. I have another matrix down here. Now listen attentively. There's a step to this thing. There's a step. So this is what I used to use. I always select my matrix A given to me. After doing the partitioning, I used to call this part, is that you call it C, D, E, and F. I don't want to use C, D, E, and F. Please and please. What I want to use now, I want to call this one my beta 1. Let's call it beta 1. Okay. The partitioning. This is partitioning, right? Whatever matrix I have here, let's call it beta 2. Whatever matrix I have here, let's call it beta 3. Whatever matrix I have, let's call it beta 4. So I have beta 1, beta 1 to beta 4. Please take note. Such that your beta 1 must not be equal to 0. The determinant of beta 1 must not be equal to 0. I already explained that. The determinant of this question must not be equal to 0. This is the key point of partitioning method. That's the first thing you need to check. So when you now notice that, okay, I know my B1 to be this matrix, B2 is this, B3 is this, B4 is this. So what's my A inverse? It's A inverse I'm looking for, right? So now let me tell you what A inverse is going to be. Now you need to follow these 6 steps. There are 6 steps to follow to get this final answer. If you not follow those 6 steps, forget. And if you cannot cram, you need to even cram the 6 steps. If you cannot cram it, forget about partition method. So you need to be very, very smart enough to cram this formula here. These 6 steps. So now listen attentively. To look for A inverse, the final answer for A inverse is actually of this format, whereby A inverse is always equals to x, y, z. X, Y, Z. So I don't know which other letter to use. Let me just use another letter. Let me use W. There's a reason why I don't want to use W, X, Y, Z. Start from X, Y, Z. Then the last one, fill it with W. Please, this is your final answer for A inverse. So what is your X? What is your Y? What is our Z? And what's our W? I will explain now. Listen attentively, I will explain. Just calm down. So the first step you need to do now, the first I said we need 6 steps. Step 1, 2, 3. Okay, 4, 5, 6. Are you ready? Yeah, okay. So for the first step that we need, you need to find the inverse of that beta 1. Start with this beta 1. That's why I said if the determinant of this thing is equal to 0, I don't think you'll be able to find the inverse. It will not be possible. If eventually this determinant gives you 0, then there will be a problem. You'll not be able to find the inverse. So all these steps becomes useless. Okay. So you need to cram these six steps, please and please. First thing I recall that you can easily remember that okay, Noah said the first step is to take the inverse of this condition, this first matrix here, beta 1. Find the inverse. That's the first thing you need. So the second steps now says there exists, I use alpha. There exists a particular matrix which is alpha, okay, such that this second step, there exists an alpha that will be equal to, alpha will now be equal to, okay, are you listening? You will now have to multiply this B3 and that inverse. Relate this first one and this one like this. Here, you will now have to multiply beta 3 and the inverse. That's for step 2. You must cram this two. If you not cram it, then you're in trouble. You will not be able to solve the question. Forget. First, I repeat, find the inverse of that beta 1. Second step, there exists alpha. Call alpha. Normally, I'm supposed to just say, okay, step 2 is beta 3 times the inverse. But make sure that that's beta 3 times the inverse. Call it alpha. So that it's going to reduce. So that it's going to take this as a single form. Okay, this product means alpha. That's all. So when you now get to this point, the remaining steps are for these values that you have here, starting from W, the vice versa, start that's in order rather. Okay, let's say not really like in reversal, when you reverse it this way, W, I started with X, Y, Z, W. So here in this case now, your step 3 now will now be W is equal to what? I'll tell you. Then followed by what? Z is equal to, just hold on, I'll tell you. Followed by Y, then followed by Z. So whatever you get here, just come here and put it. Whatever you get here, come here and put it. Whatever you get for Y, put it. Whatever you get for Z, sorry, what am I writing? Sorry for that. This is X rather. Whatever you get for S, put it here. So if you just write everything out, then that's final. That means if you can actually get an answer for this, you're almost close to the final answer. If you get an answer to this, you're almost close to this. So that's just the concept. So W now, what is the formula for W? For W, the formula is actually equal to, you must be able to cry. I've used B1, I've used beta 1, I've used beta 3. So I've not used beta 4 at all. So to get your W is now equals to, you open a bracket, okay, and then remember that Noah said there's an inverse up here. That's the pattern. So what are you going to have inside this bracket? The combination of this. Okay, I've used this combination for this second step. Now for this third step, you now use this combination, beta 4 and beta. So here I use times, okay, but here that will be beta 4. You use minus. If you use times here, remember that Noah said you use minus here. Just to remember, you need to remember the pattern. Okay, we relate this and this together. Beta 4 minus what? Beta 2. But something is missing. This alpha will now come inside this bracket. You must put it in. So alpha will multiply that beta 2. Please find the pattern for yourself. That's it. So you can just clean. Well, okay, what if I want to start? Okay, let's say I just go up here and I want to quickly recall without copying. Don't let us copy. What was the first step? Let's quickly refresh our brain together. First step, I said find the beta inverse, beta 1 inverse. Okay, you now have beta 1, beta 2, beta 3, and beta 4. This was the partitioning I used, Abi, right? So I said first step, find the inverse of this one. So without copying, let's refresh our brain together. What was the step I said for beta 2? I said for step 2, there exists an alpha that will be equal to the relationship between, you relate this and this together, and which is what? Beta 3 times beta 1. But you are relating it with beta 1 inverse, so not just beta 1 only, beta 1 inverse. This step comes in, this steps comes in. So for the third step now, which is for W, let's our final answer for A inverse, abi, is x, y, z, w. So you know how to fix this thing accordingly. Please don't make any mistake. W followed by z, followed by y, and the last one followed by what? X. So for this step now, I said open a bracket and put inverse. So it's just have a pattern so you can recall it anytime. I remember during my time, so I crammed this. So when I got into the exam, I was able to write out the six step. In fact, before you start solving anything at all, actually what by, and you check that question, and you notice that you saw partitioning. Quickly, before you start solving anything, quickly write out this six step out somewhere. So that when you need it, you'll be able to recall because it's still fresh before you enter the exam hall. By the time you start solving all questions and then you now want to recall this, you must have been tired. So you're not able to recall it. So immediately when you enter the exam hall, when the question is being distributed and you check the question, wow, hey, partition method comes out in this question number so and so. Quickly write out the six steps so that you not forget. So for the W part now, I said we are relating this second column, B4 and B2. So you write your B4 here. If you have times, this one will be minus, then you write your B2. So I said B1 inverse comes in, alpha 2 will come in this place. So alpha comes in now. So that's just for third step. So let's continue with our pattern again. So I'm trying to, I think we are good on step 1, 2, 3. Now let's go to step 4. How does step 4 looks like? If this alpha comes in, automatically this W2 must also come into this formula here. Do you understand? So that is just it, and that ends everything. I don't think y will not z will not come into where you have y, and I'm very sure only y will come into where we have x. So let's check the pattern for z. What is z? Here I deal with minus for the z part. Okay, for this, in fact, for the z and y part, start with it minus. That's what you must remember. For this part now, start with minus so that you just find the pattern so that you can recall. So I'm not supposed to do. I'm so normally, what I'm supposed to do here is to just give us these six steps. But I'm still trying to look for a way to explain so that you understand it, so I can easily recall. That's why I'm giving you all this short pattern. So for this step 4 and 5, put minus minus here. Okay, put minus minus in this place. So what I need to have after this minus for this z, I said w will come into this place. So you write your w. If w comes in, you see this alpha, there is this alpha that we actually brought from somewhere. So this w comes in. So this one is very simple. The z is very simple to solve. Just use your w and multiply with alpha. That's all for w. So now for y we now go back to this beta 1 inverse. Pick the beta 1 inverse, multiply it by what? Beta 2, and then multiply it with what? This w will also come down. I don't know whether you can actually recall this. Just make sure that you cram it. For y, pick beta 1 inverse times beta 2, then times w. So what's now your x? X now will still remain as this beta 1 inverse as the first one. Okay, then instead of having minus this beta 1 inverse, instead of having minus as the first part, okay, it is y that will now come into this place. Y will now come in. This is w alpha. This one will now be y alpha. So these are the steps that we need to follow to get our. Just follow these six steps. So let me reduce it a little bit. I don't know whether you can still see it. Now let's start with step one. Let's start with step one. Step one says find beta 1 inverse. That means I want to look for the inverse of beta 1. So let's go and look for beta. What's beta 1? 2140. Abi? Look for the inverse of 2140. To look for inverse of this, the inverse of this thing means 1 over determinant. Find the determinant of this. This times this times this minus. That's minus 4. Find the adjoint of this 2140. The adjoint of this one means swap the left to right diagonal, swap it. This is 20. It becomes 0 to have swap it. But you see the right to left diagonal, don't swap it, leave it where it is. But one thing must change. Change to the opposite sign. This is positive 1, it become minus 1. This is positive 4, it become minus 4. So then this will result to minus 1 over 4, 0 minus 1, minus 4, 2. So then this is what we have as our beta 1 inverse. So I don't like putting it outside. I love putting it inside. So this is scalar multiplication of matrix. Minus 1 over 4 times 0, that's 0. Minus 1 over 4 times minus 1, that's 1 over 4. Minus 4 times this, that's 1. Over 4 will cancel 4. And if this multiply this, I will have minus 1 over 2. So this is my beta 1 inverse for step 1. I still want to zoom it out there. So now let's go to step 2. What's going to be our step 2? Let me increase this thickness a little bit. So for our step 2 now, you know what we're going to have. Let's check. Our step 2, there exists alpha which is equals to beta 3. What's our beta 3? Let's go and check. Beta 3 is this third one. 3, 2, 1, 3. 3, 2, 1, 3. Beta 3 times this our answer that we got here, right? 0, 1 over 4, 1 minus half. If you don't know how to use calculator to solve matrix, you're going to have a problem here. Because it can't be, see, if you go and see, if you say you want to use your eyes to solve it, or you want to just solve it manually, forget, there's 80% chance that you do mistake. So it's always you use your calculator. So if you multiply this and this together using your calculator, I'm very sure the results that you will get 2 minus 1 over 4, you will get 3, and this one will give us minus 5 over 4. You can try it out, check it out. This is going to give us for step, this is our answer for step 2. So now let's solve for step 3. For step 3, we need to look for W. For step 4, we need to look for Z, then Y and X and that. But let's solve for W first. W, the formula is beta 4, abi. You need a bracket here, put an inverse. I don't know, there is not enough space for that. I have to, let's stretch it this way. Inverse, abi. So here in this case, I have matrix for beta 4. Let's go and look for beta 4 matrix. Beta 4 is what? 2, 0, 2 minus 1. So I'll put 2, 0, 2 minus 1 here, abi. Then minus, what's my alpha? The alpha I just got, alpha is equals to this final answer here, which is 2 minus 1/4, 3 and minus 5 over 4 in that case. Then times beta 2. Now what's beta 2? Beta 2 is let's check, 1 minus 2, see it here, 1 minus 2, 2, 1. 1 minus 2, 2. Like I said, calculator will do this for you straight up. On calculator, call this one matrix A, call this one matrix B, and call this one matrix C. Put the value, put the dimension, the values for the dimension, for this dimension and for this dimension. So at the end of the day, on calculator, you just press mat A. In fact, you can do everything at once. You can open the bracket first on calculator. Then there's a way you can actually display mat A. There's a way you can actually press mat A on the calculator. Press mat A, then you press minus mat B. But you open the bracket here, then press mat C. Then you now close the full bracket. You now press exponential. There's a place, no, it's not exponential. There's a place on calculator where you see raised power minus 1. You see it. So it will display like this. It's not going to display, it's going to display like this. Exponential minus 1. That's how it's going to display. So it will give you the straight answer. I don't know. I didn't think I can display my calculator on this screen now. It would have been very easy for me to do that. So if you evaluate this one, if you do okay, this times this, you get an answer. You still have a 2 by 2. If you multiply 2 by 2 matrix by another 2 by 2 matrix, you get less than 2 by 2 matrix. So if you subtract, you get an answer. Then you now find the inverse, just like the way we've done it here. You can also solve it manually, but I would advise you to use calculator. So when you do that, you get your W as our value for W, we will have it as minus 25 over 13. You can check it out. And we have this one as 17 over 13. We also have this one as 6 over 13 and minus 2 over 13. Okay, that's for W. So for step 4, we need to look for, I think that should be Z. We need to look for Z. I think that should be Z now, right? Z is minus W alpha. Minus W times alpha. Step Y also, step for 5. This is also minus. Can you actually recall the pattern? Can you still recall what this one is? This one says you should go and pick. I can still remember without even scrolling up. Beta inverse. I'll pick beta inverse. Then what's the next thing we have to pick from there? This is not really easy to remember, but at least just try. I think I'll multiply it by beta 2 also. Then finally with what? W. I think this was the formula for Y. So just find a way to recall. Sha. If you don't remember, if you cannot recall, just cram the first step, please and please. That's the important thing. That's why I'm repeating it again and over again. So my W now, I have it as this is the minus outside. I have my W as minus 25 over 13, 17 over 13, 6 over 13, minus 2 over 13. So then times alpha. Where's our alpha? See our alpha value here. 2 minus 1 over 4, 3 minus 5 over 4. That's what I have. So if I multiply this and this together times this minus, so we have our Z. Our Z value now, we usually have it as minus 1 over 13. This is my Z value. 15 over 13. I will have this as minus 6 over 13 and minus 1 over 13. This is what I will have as my Z. So I've gotten one answer for my inverse. This is my final answer for A inverse. I've gotten Z already. So I still okay, I've gotten W self. I either have answer for W and Z. So what I have left now is just Y and X. So if I get Y and X now, then I'm done. So what's the what's this one now? This one will be minus. I remember that my beta inverse was 0, 1 over 4, 1 and minus 1 over 2. Is that what we got? Let's check. Our beta 1 inverse, where is it? Yes, see it here. So what's our beta 2 is in the question. You can go and check it. For beta 2, you have our beta 2 as 1 minus 2, then 2 1 also. Then our W, what do we get as our W? See it here. Minus 25 over 13, 17 over 13, 6 over 13, minus 2 over 13. So if you multiply all this together using your calculator, together with this minus, you will have your Y as 11 over 13 minus 8 over 13. You have 15 over 13 and minus 5 over 13. The beauty about these things, I always notice that the fraction here, the denominator will always be the same all through. If you don't have over 13 for W you always have over 13. For Z you always have over 13. For Y, that's the Y. If the question is being changed, if you don't have the same value as the question that is here, I'm very sure if you do your computation and you notice that you're having something like over, let's say you are having something like over 23, automatically if you calculate for Z too, you must have over 23. If you don't have over 23, that means the highest thing you can actually have is maybe 23 times 2. Let's say you now have 46. You can have over 46 too, which is possible. It can appear to be 46 too. Okay, it can appear to be a factor. But make sure that if you're having over 13 for W, this one too must be over 13. If you're not doing your calculation and this one is 6 over 13 and this one is now minus 2 over 20 something, 27, it does not really make any sense. Check your workings again and then correct that. So this for Y. And as for my Z, can you still remember the final answer for Z? How do we even give? I think for that Z, we actually said Z as, sorry, for X rather. That's the last one we are looking for. For X, I said we just bring this one down, bring it down, okay? And then take a minus. This minus will be here. Then you pick this Y and alpha. Oh, yes, and alpha. I got it. Let's check. I think that was what I said. Here, see it here. So then you know your beta inverse as 0, 1 over 4, 1 and minus 1 over 2. We know our Y, that's what we just got now. 11 over 13, minus 8 over 13, 15 over 13, and minus 5 over 13. Then alpha, we got our alpha as this. Our alpha is 2 minus 1 over 4, 3 and minus 5 over 4. So if you multiply all these things together, multiply this and this minus this, then you have this result. Please take note. You have our x now will just give us 2 over 13. You can verify yourself. Okay, 15 over 13 and minus 5 over 13. If you know you don't know how to use calculator to solve matrices, you can check it online. Just type it on YouTube. Just type how to use calculator to solve matrices. You just watch the video for a while and then you can easily flow. This is not something that is really hard. I also have a calculator. I have a video on how to use calculator to solve matrices. But that one is for just determinants. We are not dealing with determinants here. So I already have my final results. Let's write everything. Okay, my result for x is, let me write it out very well. The result is 2 over 13 minus 4 over 13, 15 over 13 minus 5 over 13. This is for x. Y, y value, I got my y value as what? The y that I got, I think this is minus 9. Please take note. This is minus 9. It's 9. It's 9. Wait, oh, for x, did I even write this thing clearly? No. This one is minus 2. For x, this is minus 2. Please, let's take note. If you solve it out, this one is minus 2, while that one is minus 9. And I have 2 and 13. Please take note. I actually write this. That was a mistake I did. Minus 5 and 15. That was a mistake I did. So this is 2 and this is minus 9. Please, let's take note. Let me clear this thing very well. This is minus 2 and this is minus 9. So for y, let's recall, the y I got is 11 over 13 minus 8 over 13, 15 over 13 and minus 5 over 13. So for z, I have my z as minus 1 over 13, 15 over 13, minus 6 over 13, minus 1 over 13. And as for the w, which is the last part, we have our w as minus 25 over 13, 17 over 13, 6 over 13, minus 2 over 13. Please take note, that's for the w part. So therefore, the A inverse I'm looking for is actually equals to this x, y, z, and w, right? So that would be equal. Remember that A is coming from is a 5 by 5 matrix, so you must also have a 5 by 5 matrix here. So what's my x? See my x here. So let's write it out. 2 over 13. So I don't want to write it that way. So it take a lot of space. But let me just reduce the font size. Yes, let me do it this way. And then this is what I'm going to do. So now let's check. I still want to clear this off. So my A inverse now, I want to open a full bracket of this length. My x, see it here. 2 over 13 minus 4 over 13 minus 2 over 13 minus 9 over 13, right? This is my x. My y now follows 11 over 13 minus 8 over 13, 15 over 13 minus 5 over 13, right? So my z follows down here. Is it a 4 by 4? I think the matrix says it's 4 by 4, not 5 by 5, if I'm not mistaken. Yeah, it's 4 by 4. It's 4 by 4. This matrix is 4 by 4. Sorry for that. So I have to have a 4 by 4 matrix at the end of the day. So my z is this. See my z position. So I will put it here. Minus 1 over 13, 15 over 13, minus 6 over 13, right? And minus 1 over 13. While the w part is minus 25 over 13, then 17 over 13, then 6 over 13, and minus 2 over 13. Whereby this is actually equivalent to 1 over 13 is common all through. Okay, then you now have the remaining results as 2. 1 over 13 is out, you let it 2 times this, we have this one back. You have minus 4, then you have And this is not minus 4, this is minus 14. Please let's correct that. This is minus 14. I don't know why I'm making that mistake for. Is it minus 4 or minus 13? You can help me confirm that, Sha. I can't really remember. After solving it, because what I have here after solving is minus 14. But you can confirm, please. You can confirm. Use minus 4, you can leave it as minus 4, but I think it's minus 14. This is 11. This is minus 8. Okay. And I'll have the next one as minus 2, minus 9, 15, minus 5. I have 1 here, Abby. And I should have 15 here. I should have minus 25 here. I should have 17, minus 6, minus 1, 6, and minus 2. So this is our final answer for the A inverse. So these are A inverse. Now recall that they now ask us to look for this last part. They ask us to solve this equation. I think they ask us to solve the system of equation. Let's check. Let me go and check the question again. Use the partition method to find the inverse of matrix A. We've answered this one. We've answered this one. Hence, solve the system of equation AX is equals to B. So now, where B is equals to what? This. Can you see B? B is this. Minus 10, 8, 7, 5 transpose. So now let's go ahead and solve that. Solve the system of equation AX equals to B. This X is a vector form. Okay? It should be in vector form. Whereby, so if you want to solve this system of equation now, it's not something that is really hard. I already have my matrix A. My matrix A is actually okay, this is A. I have my A inverse, right? So if you have AX equals to B, just divide both side by A. Divide both side by A, divide both side by A. If A cancel A, so my X now is equals to, this one is 1 over A times B. And my 1 over A means A inverse times B. So this is equals to A inverse times B. So you now are going to do that. So that means this X I'm looking for now. You know, when they ask you to um, solve a system of equation, that means you are looking for X, right? So my A inverse is what I got as 1 over 13 of those results as 2 minus 14, 11 minus 8. I want to write it out again. Minus 2, minus 9, 15, and minus 5. And this one I have it as minus 11, 15, minus 25, 17. And this is minus 6, minus 1, 6, and minus 2. So my B now, recall that B is given to us as minus 10, 8, 7, and 5. Transpose. So if I evaluate this guy here, what is the transpose of this? That is in horizontal form. So the transpose of, if I want to remove that transpose now, my B will now be equal to, this my B now will be equals to something that if I evaluate, if I don't want to see this transpose again, that's how I will take transpose. That will be in vertical form. Minus 10, 8, 7, 5. Okay, that's what I'm going to have. So then you have to use your calculator. Calculator does not have 4 by 4. So that means you have to multiply this and this. Okay, 1 over 13. This will multiply this. That is 2 times minus 10. That's minus 20. Minus 14. Minus 14 times 8. Minus something. Put it here. 11 times 7. That's plus 77. Minus 8 times 5. That's minus 45. So that aside. So I've done this and this done. Next one is to do this and this one too. So you put your answers here. You have everything plus. So you do this one too. Then you do this one too. You add everything together. So if you do that now, if you can actually multiply that on your calculator, after adding all these ones, you have this result here as I think this will give us. I did not really show the workings. I did not really show the workings, but I'm very very sure if you add all these ones together, I still have 1 over 13 outside. I still have 1 over 13. But if you try to solve all these things out, okay, like okay, after adding this, you have an answer, then times 1 over 13. I'm very sure you'll be left with just minus 15 here. So that means maybe after, I think that's what you're going to have in this case. Maybe if you add all these ones now, that will be 13 times 15. Coming, that's 15, 6, 3 times 1 is 3, 5, 8, 1. So it seems in this place now I will have 185. I think that's what you're going to have here. You have 185 in this case. So that when you now multiply this and this together, you'll be left with. So you have minus 185 in this case. So that when you now multiply this minus 195 by 1 over 13, you now have minus 15. So I don't know what I'm going to have here to do the same thing by multiplying this second row by this first column, third row, first column, put your answer here. Last row, first column, put your answer here. So you put your final answers after adding. So you now use this answer here to multiply this 1 over 13. If you do that, you will get minus 21, and this you get 0, and this you get 23 respectively after multiplying. So that means my vector x is always of this form: x1, x2, x3, x4. So they ask us to solve the system of equation. So the solution to that system of equation is that x1 is minus 15, x2 is minus 21, x3 is 0, and x4 is 23. So that's how it works for that. So I think this is just the remaining topic I want to explain under my 332. Okay, I've done physical tutorial with you guys on. I started with interrupting, started with interrupting scheme, whereby I was able to use the interrupting scheme for when you have just one variable, and when you have more than, when you have a function in terms of x and y. When you have something like this, and that's it, when you have x and y also. I've explained this too, and I've also explained Taylor series method, ELA implicit, ELA explicit, Roger-Cooker, Gauss-Seidel. I've done that with you physically. I've explained the physical. I've explained those topics to you physically in our physical tutorial rather. So I also explained Gauss Jacobi. So I've done a lot. So I think this is the remaining part of take 32, and it actually ends here for now. For now, it actually ends here. So that's all I have to just explain for now on this. So please take note of this my explanation. So that's how it works. That's how it works. The only thing I just noticed about this course is you must be familiar with your calculator. You must know how to use calculator before you get into the example. You must know how to use calculator. So find all means to watch other YouTube videos on all these petty things on how to use calculator to solve matrices. So that's all I can explain for now. Thanks for watching.